Okay, so this first video is going to be 1.0 domain and range, and it should feel like a review. Now, after I go with the title, I jump right into the objectives. So our first objective is to graph single variable inequalities on a number line, and our second objective is to review domain and range of any graphed function. Now, the first one is a review to get us into the second one. Now you'll see I like to put a lot of vocabulary words. So our first one is inequality. And the reason why I do this is we need to have the same math language in order for us to effectively communicate about math, right? If you're saying that thing over there in conversation with me, it's not clear. If you're reading something about math, they're going to use the terminology. So I am going to expect that you guys use this language with me. So we have a word here, inequality, and it is a math sentence that compares expressions. And expressions are, it's really anything. X is an expression. X plus 2 is an expression. 12 by itself is an expression. So when we say we're comparing expression, we're just comparing two of those things, maybe sometimes more. So I can say X is greater than 3. That would be our first symbol, right? And then we can do Z is less than 5. Now, both of these are very similar in the fact that the number you see on the other side cannot be a solution for the variable. So when I plug something in for X, I'm looking for a true statement. So 4 is greater than 3, right? 5 is greater than 1. Those are all true. But if I plug in the number 3 is greater than 3, that's false. Okay, because 3 is not greater than 3. Now, just as a reminder, the big side opens up to the bigger number, and then it points to the smaller number. Okay, so what I just drew there was like the alligator chomping the bigger side. Okay, and a greater than and less than, it's really the same symbol, right? They're just reversed. So I can read this right here. I can say X is greater than 3, or I can say 3 is less than X. Okay. Now, Z is less than 5. I think we're pretty good on that one, right? We're saying all the values that can be plugged into Z is less than 5. And then let's go to Y is greater than or equal to, let's do -2. Very similar, but it could be -2 now as a correct solution. So I could say 5 is greater than or equal to -2. I could say 0 is greater than or equal to -2. I can even say -2 is greater than or equal to -2. It just needs to satisfy the greater than part or the or equal to. And then the same thing here. I can do A is less than or equal to -5. So -10 is less than or equal to -5. That's true. -5 is less than or equal to -5. That's true also. Okay, so here is our first concept. It's going to be graphing single variable inequalities on a number line. And I'm just going to jump right in and show you an example. Here we're saying that all of X is less than 2. So that's a lot of different numbers, 1, 0, -1. So to show that on a number line, I'm going to put some numbers. And I generally try to have 0, and I try to have some positive and negative numbers, but it just depends on your situation. And I'm going to take the number 2, I'm going to put a dot on it. Like that. Let me do that in blue. Let me put a dot. All right. Now I specifically chose an open dot because 2 is not a solution. 2 is not less than 2. That would give you false. So the open dot represents that 2 cannot be a solution, but we want all the rest of them. Okay. And we do it that way because 1.99999 is the solution, but that would be really tough to get right up to 2. So we just use the open dot. Okay. Now, in thinking about the direction to fill in the solutions, think about which ones are true. I could put a 0 here. 0 is less than 2. That's true, right? I can do a -3. That's less than 2. That's true. And I can see those numbers right over here, right? We can see them on the line that I just drew. But I look at numbers like +3 and I write that, well, +3 is not less than 2. That's false, okay? So you just kind of look to the left or the right of your dot, and that'll help you figure out which one to do. Now it's the same thing when X is greater than or equal to -2. I'm going to go and, I'm going to put some numbers. And, you could actually, sometimes I just do this. I just kind of fill in the ones that I need to see. Totally up to you. And I got a -2, so I'm going to put a closed dot on -2, because in this situation, -2 could also be a solution. And I'm going to fill in to the right, okay? Because I can see, I can do a bunch of tests here, right? Where's my colors? The number 0, right? 0 is greater than or equal to -2. That is true. 0 is a bigger number than -2, because -2 puts you into the negatives, into debt, right? So 0 would be better than owing something, right? +2, same thing. 2 is greater than or equal to 2. That's true. So that's the right direction to fill in. Now, this is my examples. And the next thing I want you to do is I want you to pause and try this. If you're on Edpuzzle, it'll stop you. If you're on YouTube or whatever place you're looking at this, you're going to want to just pause it on your own and give them a try. Okay. Our next concept is going to be writing inequalities from a graph. Okay. Now, it's just going to be the complete inverse of what we did before. Before we had an inequality, we wanted the graph. Now we have the graph, we want the inequality. So if I zoom in on this one, you can see all the pieces of information are there for us. We see our open dot right here is on 4. So I know I'm going to need a 4 in my inequality. And then we just have to focus on the direction, right? Is our x, the values more than 4? Is it less than? And here you can see we're going to the right. We have the number 5. 5 is greater than 4. So I could jump over and x is greater than 4. If it was going the other way, it would have been x is less than 4. Now our second one here, very similar, right? We just got to pick the information off. We see our dot is on 3, put a 3, and this time we see a closed dot, not an open dot. So we know we're going to have the or equal to, and we follow the numbers. 2 is less than 3, 1 is less than 3, 0 is less than 3, and so forth. And it's also got the closed dot, so it's going to be x is less than or equal to 3. So this one should be, pretty straightforward, right? Pick the information, put it together, and then you can always go back and check if it's legitimate. Now, I want you to now pause and try and give these a go, and make sure when we get to class, if you didn't get these, that would be the perfect time to bring up these problems. We'll always start with going, how did you do on these? So here we have our third concept, and it's going to be about domain and range. And finding it from a graph, okay? Now, all of these are graph functions, and a function takes a domain as an input and gets a range as an output. So if I had a function, I'm just going to write the word function, but it would be things like f of x equals x or f of x equals x plus 2. The domain goes into it. You do some calculating, and out pops the range. So the domain is also your x values, and your range is your y values. So when I ask what the domain is of a function, I'm only asking you at this point to tell me the story about the x values. And if I look at this first graph here, I know we don't see these arrows, but this is a quadratic function, and it is expanding in both directions. And it's just always getting wider and wider and wider. So when you look at this, it's almost like all of the numbers for x could be an input, right? Because all of these, all these points tells you an x and a y, an input and an output. So everything in the x value is a solution. So I'm going to do a squiggly line through the x so that I know all of them are solutions. And the way we would say that is our domain is all real numbers, because it's got them all except for the irrational numbers, right? Now for the y-axis, we can see that there's a stop, right? I don't see any -10, -5 numbers as outputs. I only am seeing the positive numbers. So I'm going to look at my y-axis. I'm going to put a dot here. And these squiggly lines you don't have to do. I'm doing this so it's easier for you to see what I'm talking about because we're digital. And you can see that it's all of the y values up, okay? And only the y values up. So the way we do that is with an inequality, which is why we reviewed them. We have range is y is greater than or equal to 0. And if you think of those graphs that we were doing, that blue squiggly line I did is kind of the same thing as that single variable being graphed, right? We had a starting point here, it would be 0, and we're going all the way to positive infinity. That's why we got y is greater than or equal to 0, because it's also on 0, okay? So let's look at the next one. And I'll keep that in view. This one's cut off a little bit here, right? When I look at the x, so we're going to look at only domain first. I see I have, I have 0 as a value. I got 1, 2, and so forth, all of those. And this is going on and expanding. And so that's going to go this way, okay? So my domain is no longer all real numbers here. I can see that it's starting at 0, and this would be x. So x is greater than or equal to 0. Now, if it wasn't a solution, like if it was, for an example, where x is greater than 0, you would see an open dot on that area to denote that it's not an or equal to, okay? And then we got to look at the y. Let me get that, okay. So same thing here, went all the way down to 0 for the y, so I'm going to put that and squiggly up. We have all of these values, okay? Now let's look at a point. We have a point here, right? We can see down to the x, we can see over to the y, all right? Those squiggly lines you draw, you should be able to do something like that to make sure they're in the right direction. And then we have our range, we'll do that in blue. And here this is going to be y is greater than or equal to 0, okay? So they're both kind of cut off. This function cannot take a -5 as an input. Can't take a -1, right? It's going to only take 0 and on. And then let's go to this one. Now, this is a linear function. It's going on in both directions. And you start to look at the x-axis. Well, I go to the right, well, I'm getting everything. And go to the left, well, I'm getting everything, right? Because it continues to be on that graph. I look up and down. Hey, wait a minute. I go down, it keeps going. Okay, I go up, it keeps going. So for both of these, for domain and range, I'm just going to put D, it's all real numbers. And you're really going to see that for all of your linear functions, except if there's a constraint put in where it got cut off at a specific point. Okay, so hopefully you can see why we reviewed inequalities. You're going to be using them a lot for domain and range. We are just basically using inequalities to tell the story of what are my domain values and what are my range values. Now, you got 2 to do on your own. These look a little bit different. Don't worry about the way that they look. Focus on what x values are there, what y values are there, right? What domain and what range. Use your inequalities. Use your all real numbers when it's appropriate. Okay, so the last thing I want to ask you guys is to kind of think about this situation, right? Does it really matter which side of the inequality the variable is? So is x greater than 2 the same thing as 2 is less than x? And is x is greater than -2 the same thing as -2 is greater than x? Okay, because this is something I see confuse students a lot. All right, and then finally, okay, come prepared with questions to class. If you were trying the problems and you were really confused, first thing we get to class, that's what I want to talk about, okay? Making these videos has actually been really, really hard. So sometimes I might be forgetting to put something in them. So just be ready to ask questions. If you don't get it at the end of this video, keep trying, and then we'll try and cover whatever we can when we get to class, okay?